Welcome, future tech explorers. Today we're diving into an amazing tool called Apache Airflow. Think of it as your digital assistant that never sleeps. It helps you build, schedule, and monitor workflows automatically. We're going to explore the complete guide with real-world use cases, learning how to programmatically author, schedule, and monitor workflows. Get ready for an exciting journey into the world of automation. So, what exactly is Apache Airflow? Apache Airflow is an open-source platform designed to programmatically author, schedule, and monitor workflows. Let's understand the 4 key concepts that make Airflow magical. First, we have DAG, that stands for Directed Acyclic Graph. It's a collection of tasks with defined dependencies. Think of it like a recipe, where each step depends on the previous one. Next is task, a single unit of work like running a script or transferring data. Each task is like one ingredient in our recipe. Then there's the scheduler. This triggers tasks based on time or dependencies. It's like your smart alarm clock that knows when to wake up each task. Finally, the executor. This runs the tasks in various environments. It's the worker that actually gets things done. These 4 components work together to create powerful automated workflows. Let's explore our first real-world adventure. Use case 1, e-commerce data analytics pipeline. Picture this scenario. An online retail company needs to process daily sales data from multiple sources. They're collecting data from website transactions, mobile app purchases, in-store POS systems, and third-party marketplaces. Their goal? Generate comprehensive business intelligence reports for management decision-making. But here's where it gets challenging. Let's look at the traditional challenges they face. Manual data extraction from multiple systems. No visibility into pipeline failures. Difficult to handle dependencies between tasks. No automated retry mechanisms. Hard to scale during peak seasons. Now here's our simple explanation. Think of this like automatically collecting all your store receipts from different cash registers every night, organizing them, and preparing a summary report for the next morning. But instead of receipts, it's digital sales data from your website and mobile app. Pretty cool, right? Now, let's see the magic happen. Here's our e-commerce pipeline comparison, without versus with Airflow. Looking at data extraction. Without Airflow, you have manual scripts run individually, prone to forgetting steps. With Airflow, you get automated extraction from all sources with dependency management. This is solved by Airflow's DAG functionality, which ensures tasks run in the correct order and wait for dependencies to complete. For error handling, without Airflow, the pipeline fails silently, requiring manual checking. With Airflow, you have built-in retry mechanisms and failure notifications. This is handled by Airflow's task retry feature and email operators that automatically send alerts when tasks fail. Regarding monitoring, without Airflow, there's no visibility into pipeline status or performance. With Airflow, you get a real-time web UI showing task status and logs. This is provided by Airflow's web server and logging system that gives you complete visibility into every task execution. For scalability, without Airflow, it's difficult to handle increased data volume. With Airflow, you have parallel processing and resource scaling. This is achieved through Airflow's executors like Celery Executor and Kubernetes Executor that can distribute tasks across multiple workers. Finally, scheduling. Without Airflow, you're stuck with cron jobs with limited dependency handling. With Airflow, you get sophisticated scheduling with complex dependencies. This is powered by Airflow's scheduler component that understands task dependencies and cron expressions for flexible timing. The difference is night and day. Ready for our next adventure? Use case 2, machine learning model training pipeline. Here's our scenario. A streaming service company wants to automatically retrain their movie recommendation model weekly. They need to fetch fresh user interaction data, prepare features from viewing history, train multiple ML models, evaluate and compare performance, and deploy the best performing model. The traditional challenges are pretty tough. Manual model training cycles. No systematic model comparison. Difficult to roll back to previous models. No automated feature engineering. Hard to track model performance over time. Here's our simple explanation. Imagine you're a movie theater owner who wants to automatically figure out what movies each customer might like. Every week, your system looks at what movies people watched, learns their preferences, creates a smart suggestion brain, tests how good it is at predicting, and then uses the best version to recommend movies to customers. It's like having an AI assistant that gets smarter every week. Let's see how Airflow transforms ML pipelines. ML pipeline, without versus with Airflow. Resource management. Without Airflow, compute resources run continuously, wasting money. With Airflow, you spin up powerful resources only when needed through Kubernetes integration. This is accomplished using Airflow's KubernetesPodOperator that creates compute pods on demand and destroys them when tasks complete. Model tracking. Without Airflow, you have manual comparison of model versions. With Airflow, you get systematic experiment tracking and model versioning. This is enabled by Airflow's XCom feature for passing data between tasks and integration with MLflow through custom operators for experiment tracking. Deployment. Without Airflow, there's manual model deployment with risk of human error. With Airflow, you have automated deployment of the best performing model. This is handled by Airflow's BranchPythonOperator that can conditionally choose which model to deploy based on performance metrics. Rollback. Without Airflow, it's difficult to revert to previous model versions. With Airflow, you get easy rollback capability with version tracking. This is managed through Airflow's variable system and custom operators that maintain model version history and can trigger rollback DAGs. Cost optimization. Without Airflow, resources are always running with high operational costs. With Airflow, resources are used only during training periods. This is achieved by Airflow's time-based scheduling and dynamic task generation that only creates resource-intensive tasks when needed. This is efficiency at its finest. Time for our third use case: financial risk assessment and compliance. Our scenario: a bank needs to generate daily risk assessment reports by collecting data from trading systems, loan portfolios, market data feeds, and regulatory databases. These reports must be delivered to compliance officers and regulators by specific deadlines with full audit trails. The traditional challenges are quite serious. Manual data collection from multiple financial systems. Risk of missing regulatory deadlines. Lack of audit trails for compliance. Difficulty handling data quality issues. No systematic alerting for anomalies. Here's our simple explanation. Think of this as an automated financial health checkup that runs every morning. Just like a doctor automatically reviews your vital signs and alerts you if something's wrong, this system checks the bank's financial health by looking at all investments and loans, calculates how much money could be lost in worst-case scenarios, and automatically sends reports to the people who need to know. It's like having a financial doctor that never sleeps. Here's how Airflow revolutionizes financial operations. Financial risk pipeline. Without versus with Airflow. Regulatory compliance. Without Airflow, you have manual processes, difficult to maintain audit trails. With Airflow, you get automated audit trails meeting HIPAA/SOX requirements. This is provided by Airflow's comprehensive logging system and task instance tracking that records every execution detail with timestamps and user information. Deadline management. Without Airflow, there's risk of missing regulatory deadlines. With Airflow, you have guaranteed timely delivery with automated scheduling. This is ensured by Airflow's SLA monitoring feature and scheduler that can send alerts if tasks don't complete within specified timeframes. Data quality. Without Airflow, bad data propagates through the system. With Airflow, built-in validation steps prevent bad data propagation. This is implemented using Airflow's sensors and custom validation operators that check data quality before allowing downstream tasks to execute. Alert management. Without Airflow, you have manual monitoring with delayed response to issues. With Airflow, you get immediate notification of failures or anomalies. This is handled by Airflow's email operator, Slack operator, and custom alerting hooks that can trigger notifications based on task status or data thresholds. Business logic. Without Airflow, there's no handling of trading calendars or business rules. With Airflow, you have smart execution based on trading calendars and conditions. This is achieved through Airflow's conditional execution using BranchPythonOperator and custom calendar sensors that respect business days and market schedules. This level